to part 1. The three main features are a switchover from a quad to a delta, free-to-caster steering, and the direct tilt control feature. For the switchover, I'm here pointing to the quad. These dual front swing arms are removed and they are replaced by this single-sided swing arm here. The Delta uses the same wheels and the same cabin as the quad, and it feels very stable because I manually control vehicle tilt by applying force to the rear swing arms here and here. Yet my main reason for incorporating the switchover is because the Delta conforms with the 3-wheel regulation for E-assist in my area. Here is the quad. The next slide will offer a detailed look at the design of the left front wheel, and I'll describe how simple the switchover is. Here it is here. This blue unit is the hub. The two vertically aligned bolts here and here are key to the switchover. I just remove the upper and lower swing arms of the quad and replace it with this single-sided swing arm of the Delta. In this video, I'm shifting my weight and the tilt of the vehicle indirectly controls the steering. As you can see, my hands are outside the vehicle, but in everyday riding, my hands are engaged to control the tilt apparatus. Why use hub-centered wheels? Because they enhance the performance of free-to-caster steering. Here on the right are the 4 wheels for the quad, each with a disc brake attached, shown here. The next slide will show how each front wheel is combined with a front hub designed to enhance caster steering. These 2 bolts here and here also serve to establish the steering axis, shown here. Notice that the axis is aligned with the center line of the tire right here. This design enhances the performance of free-to-caster steering because fewer alignment issues are experienced when tilting or steering and suspension are combined. And there's more. The 2 vertically aligned bolts, when viewed from the side of the vehicle, create a 0-degree rake steering axis, and because this rotating axle here trails the steer axis, the wheel and this blue hub unit here perform like an everyday caster wheel which automatically steers in the direction of tilt. To sum it all up, the special designed hub and this hub-centered wheel make the switchover quick and easy, as well as enhance the caster steering, which is governed by a robust tilt control apparatus. This video shows how the mechanical tilt apparatus operates for both the Delta and quad. The hand levers and the seat bottom, hand levers here, seat bottom here, are connected with the rear swing arms here and here. Their movements force the swing arms to pivot up and down, producing a parallel tilting of the mainframe and wheels. In the next video, I use my body weight and arms to operate the tilt apparatus to illustrate controlled tilting. In the video, this is the back of my seat. By shifting my weight on the seat and moving the hand levers, I'm able to hover near the lean limit.
You're there at the limit? Yep, you're there.
The limit is shown by this white V structure.
You're there.
I then return back to upright using the tilt apparatus. Since the video, I've installed tilt stops, which has increased my comfort when I'm at maximum lean, especially at higher speeds. When direct tilt control is combined with free-to-caster steering, a very stabilized ride is experienced. Another reason for incorporating direct tilt control is to maximize the vehicle's rollover resistance. This helps to achieve a narrow-track, high-profile vehicle, which helps me to see and be seen in traffic. The mechanical tilt control helps to mitigate the effects of side winds, and the narrow track fits on cycle lanes and on urban pathways. This is the view from inside the cabin. It takes me a moment to settle in and release the park brake. The parking brake acts like a on-off lean lock device which holds the Velo upright here on this 14-degree side slope, while the tilt apparatus keeps the Velo upright while traversing the slope and smooths out the transition onto the roadway. I decided on front swing arms because swing arms travel in the plane of inclination, which reduces the lateral forces felt when riding over bumps like this wooden pallet in the video. The tilt mechanisms and full suspension help as well. Cabin ventilation. This visor vent here and each sliding window can hold any position along its upward and downward travel. This video shows the removal of the cabin. Removing the tail section will be just as quick and easy as removing the cabin. I'll be able to ride in the open air on a nice day and have full access for maintenance. No lean lock is required because the tilt apparatus functions like a permanently engaged variable lean lock device, which provides stability throughout the range of tilt and speed. And there's no need for countersteer because free-to-caster steering provides the correct steer angle for the tilt and the speed of the vehicle. I just control tilt at all times, and the steering is automatic. The name Tilt4orce QD, while it's not all that catchy, it does identify the main features of my Velo car, and that is that human force is used to control the tilt. That force is applied to 4 locations on the rear swing arms, and QD refers to the quad delta switchover. When it's completed, the Velo will have the same dimensions shown here along the bottom in centimeters. The length, the height, the width, the track. The overall width is narrow enough to push the Velo in and out of the back door of the garage. And this is the design for the tail section. Like the cabin, the tail section is the same on the Delta and Quad, but the nose cone will be different for the Delta.